All right, I've got the top of the hour. I want to welcome everybody to the NCAT from Research to Implementation webinar series. My name is Travis Walbeck. I'm the training manager here at NCAT. We've got some great guests this week. Our topic is performance potential and the quality of asphalt ThinLays, which is really a great and exciting way for the asphalt industry to keep our pavements, especially their perpetual pavements, really working and performing well. So we're going to give you a few tips and tricks on some ways to make sure we maintain that quality and show you some performance challenges that have come up over the years. So with us today, as always, is Buzz Powell. Buzz used to work for the Alabama DOT, and then he worked with NCAT, was the test track manager for a long time, and ended up being an associate director before he retired from NCAT. Now he is the technical director for the Asphalt Paving Alliance. We also have Tom Harmon with us today. He had a 30-plus year career with the Federal Highway Administration, did a lot of things like the director of NHI, was very involved in the Everyday Counts program, and helped implement SuperPave back in the 90s. And now he's been with NCAT for about a year. We also have Jim Marzell from Flexible Pavements of Ohio. He's been in the industry 40 years, just shy of 40 years, Jim. And so he started out with the Ohio DOT, and now he's technical for the Flexible Pavements of Ohio. I want to remind you all that please, if you have questions, dump them in the chat box so that we can gather them up there, and we'll do them at the end of the session. Other than that, please keep your mics muted, and we'll go from there. Buzz.
Thanks, Travis. Good morning, everybody. Travis, I can't tell from my dashboard, do we have record on for this, or do we?
Yes, sir.
We are. Okay. Thank you for that double check. Well, I'm really excited to be here again today to talk about a subject that I have very strong opinions about, the performance potential of quality asphalt ThinLays. It's fun to be here always with you, Travis, but also with Tom and Jim. All four of us have agency experience. And my agency bias going into my career was that ThinLays have kind of limited potential, and we need to be very conscious of that when we specify them and when we use them. And so my opinions have changed over the years, and I'm excited to share that with everyone today. As Travis said, these webinars now we sort of co-brand them between NCAT and the Asphalt Pavement Alliance, and so I'm very, very happy to be here to sort of stand in the gap between the two organizations now. So the way these webinars flow, I usually start out with providing some track background, and then we have typically an NCAT lead researcher come in and talk about the research, and then we have someone who come in and talk about deployment, which that's Tom for research, and then Jim for deployment, and then I usually come back in at the very end and pull it all together with practical takeaways. So the basis of the whole webinar series is the stuff that we've learned at the track. You know, the track is the proving ground for making safe change. You know, we can DOTs, the track is a research cooperative. DOTs can try things on the test track that they would be apprehensive about trying on their open roadways. And then we do 10 million equivalent single axle loadings within each 3-year research cycle. And so I'm going to dive in here and go through very quickly our history at the test track with ThinLays to kind of give you a feel for how my opinion has changed as really someone who grew up professionally in Alabama DOT based on what we experienced on the test track. And it really kind of all goes back to this Mississippi section W6 that we put on the track in 2003. It's 70% limestone, 30% kind of a sand screenings, and it's a 475 NMAS ThinLay. Mississippi had us put it on the track in 03, and it actually was either a 300,000 or 500,000 ESOL mix design. I think it was 300,000 at the time. And the idea was this is a mix that we might want to use for county roads, and you know, but it has limited use on state routes. In 2012, Mississippi came back based on an outstanding experience with that ThinLay in W6, which now is still on the track and has been down for 70 million equivalent single axle loadings. Still has a minimal amount of surface cracking, no rutting, just outstanding performance. But That 03 mix was a virgin mix with polymer binder, and Tennessee or Mississippi came back in 2012 and said, well, we want to try that, kind of the modern version of that mix. Let's take the limestone out because we have to haul limestone in from either Tennessee or Alabama, which drives up the cost. And it also now in this area drives up EPDs. And they said, we have all these surplus gravel sands that are kind of building up because of the processing that we're doing to get rock for super pave mixes. So they said, industry came in actually and said, can we find a mix where we can use all these, all of these kind of sand screening size materials that we have. And so the idea was that with this mix in S12 was it can either be a 475 or a 95. And so the specification band is pretty wide. And again, that mix is still on the track and still doing extremely well. And it had 25% wrap in it and neat asphalt. So it was building on the success of W6. That was a really smart decision. In 2012, we started doing off-track preservation test sections. Of course, Adriana Vargas, she sometimes joins us in these webinars to talk about preservation. But the basis of our preservation ThinLays that we started building in 2012 on Lee Road 159 was the 03 Mississippi mix. So we targeted that gradation, used the same limestone. We used like a sand screening size material that had virtually exact same gradation. But we put wrap and RAS in those mixes, and that was in the volumetric era. And so one of the things we learned on 159 is that the virgin ThinLays were amazing, but the 50% fine fractionated wrap and 5% shingle mixes did not do well from a cracking point of view. So they looked good volumetrically, but they were brittle. 2015 on the track, Tennessee jumped into the ThinLay game with a limestone and sand mix and a wrap. It was another 475 mix. They placed it a little thicker. When we do 475 mixes on the track or off the track, typically they're 3/4 of an inch. We've done some an inch thick, but typically they're either a half an inch or 3/4 of an inch. And Tennessee said, well, we want to place this up to, I think it was 1 1/4 inches, just to make sure it's not going to rut when we use it in a thinner placement. And it didn't. It performed extremely well. Well, when we built more preservation ThinLays in 2015 on US 280, because of the brittleness of those volumetric wrap RAS ThinLays on 159 in 2012, we did a balance mix design using wrap and RAS for those ThinLays, and it ended up being 3% post-consumer shingles and 11% fine fractionated wrap, and those mixes have done extremely well using a BMD philosophy. So we went to Minnesota in 2016 and did ThinLays on County State 8, Highway 8, and US 169. Those were wrap RAS ThinLays that were the northern match to the mixes that we built on 280, and those mixes did well. We did a recycle experiment on 70th Street in Minnesota in the summer of 2019, and we used ThinLays as a 1-inch surface mix on all of these recycle test sections where we did FDR and CIR and CCPR using foamed asphalt and emulsified asphalt with just a 1-inch preservation ThinLay surface. And then all we did was put a 1-inch preservation ThinLay on all the completely untreated test sections. It was a really poor condition, cracked up roadway. And the ThinLays that we used were the wrap version. They did not want to use shingles in this mix, but we did use 20% fine fractionated wrap, and that mix has been outstanding. But again, it was a balanced mix design. It was not a volumetric mix design. So in 2021, we put cold recycle test sections on the off ramp of the test track, and we went back to our limestone and sand 475 mix as our preservation surfaces for those test sections. This whole history that I just went through really quickly, the only bad experiences that we've had were the volumetrically designed high wrap and high RAS mixes on 159, where we had really high age binder replacement in those mixes. They were not balanced to make sure that we didn't have a brittleness problem, but we addressed that issue beyond 2012. That everything else that we've done with ThinLays including the virgin ThinLays in 2012, has been nothing but positive. So with that as the background, I'm going to stop my share and turn my camera off, and I'm going to hand off to Tom.
Thanks, Buzz. As I'm taking the baton that we're not going to drop, I just want to ask one question. When you say balanced mix design, that was like the Texas overlay tester and the Hamburg. What were the two testers using to make it balanced?
You're asking about the 2015 mixes. And yes, we used the Hamburg and we used the Texas overlay tester, and we actually dialed the mix in with mix that we ran through the plant. So I ran trial mixes with varying percentages of RAP and RAS and virgin binder content until we felt like we had good performance on both sides of the balance.
Yeah.
And those were the best tools that we had at the time.
Mm-hmm. No, I thinking of a ThinLay, that would be the two I would reach for as well. All right, so I'm going to go through a little bit more background, and I'm hoping you hear the same thing at least 4 times, because ThinLays are a tool that we used to think had a limited application, but they seem to have a lot of broad-reaching applications in here. A really good resource for you is available at Napa on one of their information series. It's 141. Describes what a ThinLay is, provides the definition, and gives some examples within it as well. So ThinLay is a thin asphalt overlay. It's a branded term. And as Travis said at the beginning, and Buzz just said, and hopefully you hear again after me, it's for structurally sound pavements. So if you're dealing with a perpetual pavement, or you've got a pavement system that just has some minor surface things you want to take care of, this is a really good tool. So ThinLays can be as thin as, according to 141, 5/8 of an inch. And you'll see in the photo there, it shows a penny sitting next to it. So I was going to put a penny next to my tape measure, but lo and behold, a dime is actually a little bit smaller, and it is actually right around 5/8 of an inch. So these can go down really thin. Typically, it's considered a thin overlay if you're below 1.5 inches. When you get into that realm, you still have to have your same considerations for nominal maximum size to thickness ratio. So for fine, we're talking 3:1. For coarse, we're talking 4:1. So your top size aggregate's going to define how thin you can go. A lot of times with ThinLays, there's polymer modified materials put in there. And it's the binder selection is always tied to the climate, based on super pave, but oftentimes you will see an SBS or a polymer in there. Recycling can be done if properly designed, and I heard the word fractionated wrap just a second ago with Buzz, and that's an example. If you're going to be using wrap, you need to have really good controls over it, because we are talking about a thin overlay. In the Everyday Counts program promoted by the Federal Highways Administration back in 2001, they had a program called TOPS, which is Targeted Overlay Pavement Solutions, which included specialty mixes for thin application. And here we come up with a whole bunch of terms that are promoted under TOPS. And if you type EDC and FHWA into your browser, it'll take you there. And if you look at EDC round 6, there's a lot of resources built in there as well. So the first one is HIMA mixes, so highly modified asphalt pavements, SMA in a thin application. High performance thin overlays are also there. Asphalt rubber gap graded mixes, which builds off of the Arizona process, but a slightly lower asphalt content. And then our good friend, the open graded friction course, which I personally love whenever I go down to my office in Alabama. Because when it's raining out, I don't have all that annoying splash and spray around me. So for thin overlays, the first question you have to ask is when. As we've said now 4 or 5 times, you need to have a functional pavement. The intent here is not to add structural capacity. So you need a structurally sound pavement. So you need to go out and do your condition survey right off the bat, looking at things like rutting, cracking, and the IRI. The photograph here to the right is an example of what not to put a thin overlay on. You can see here there's a lot of stuff going on in this area, and just putting a Band-Aid over top of this all of those moving pieces will probably work their way right back up and you'd be going out and patching again. So it needs to be in good condition, but you'll be addressing some specific issues with the thin lay. On the planning side of the house, this is a premier mix. The cost is a little more than a conventional. And it's typically, and I'll go through some things in the next slide, set out to improve specific things within your pavement. So as you're doing the preservation. So it's a thin overlay preservation technique. You can either apply it to the existing surface or milling if you've got some elevation issues that you have to deal with. So where you would do this is if you've got a pavement that's structurally sound, but you've got raveling, and that's a concern, and you want to kind of stop that raveling. If you've got oxidation within the surface, minor cracking, and I'll show an example from West Virginia with some minor cracking here in a moment, and minor surface irregularities as well. And then our friend from the safety side of the house, if you've got some skid issues, thin lay can help bring back those skid numbers. Buzz mentioned the exact example where you can do this as a wearing surface over a cold recycled base and get a really quality product. On the construction side of the house, best practices, best practices, best practices. Because it's thin, you've got a lot of challenges with that. You're dealing with your finer aggregate, which can retain more moisture. So you want to have best practices with regard to moisture, balanced production with regard to production and laydown. The surface prep is really key. You want to make sure you have a good tack coat. The other thing you want to make sure you have is a really good tack coat. Yes, I put that in there twice. I was going to put it in there 3 times, but I'll say it 3 times. A good tack coat. And then compaction as well. So when we're talking about our aggregates, fine aggregates tend to have more moisture than our coarse. So best practices are good, either covering the stockpile or putting a tarp over it. And that's true both for your fine and your fractionated fine wrap as well. On the production side of the house, you really need to have a balanced process where your plant and your paver are all working together with your rollers so that it's a continuous process. Because the one thing we don't like to see happen on any paving project is the paver to stop moving. Because you need to keep it moving because that helps you assure that you're going to get good smoothness and uniform density. Because those are 2 key things that when you get them, it's really good. And when you don't get them, you're building in failures in the future. So I mentioned an example of a thin lay, and here we are out in West Virginia. This is Interstate 64. So this is a high performance thin lay or a hop toe. And here you see the first lane going down. When you look at the other lane to the left, minor cracking longitudinally, don't see a lot of rutting. By putting this and then the next layer on top, they got a really high quality pavement back with long performance. And the cool part, when you drive down this road, it's great for listening to podcasts because the pavement is smooth and quiet. When you look at these numbers, they're amazing. IRIs, and this is showing it average in the right lane is 30, average on the pavement system is 31. Probably one of the best riding pavements you'll drive down. And so much so that West Virginia recognized it as a statewide smoothness award the year it was placed. So ThinLays not only can get rid of those minor surface issues, but they can also bring back and give you a really high quality ride. Segregation is something that we are concerned about with all pavements, but thermal segregation, especially when you're dealing with the thin overlay, is another thing you need to look out for. Here we see the paver mounted thermal profiler sitting on top of the back of the paver. And you can see here that we've got a challenge with this particular project where you've got end load thermal segregation, and then that spike in the graph is where they didn't have balanced production going on and the paver came to a stop, and then you have a cold spot. That'll really show up big time with regard to your ride and also getting uniform density on the pavement. So balanced production, and another tool that's in your disposal is looking at a thermal profile. One of the things that can help to improve the thermal profile is to remix that material before you load it into the hopper. Material transfer vehicles are always a valuable tool in the toolbox to help with that. And they're especially true when you're dealing with these ThinLays or thin asphalt overlays. I mentioned tack coat a few times, maybe 3. Here's an example of a really good tack coat going down. As always, you want to pick your right emulsion type, the application, making sure you've got your break and set. It is an engineered material. I like this graphic that Travis added in. It's a little bit of a soapbox for all of us because the thing we don't want to see is stuff like this. And down at the bottom right, you see that boot? That boot is my friend Travis's. And he likes to ask this question, do you think that tack coat's going to provide the bond that we want? Especially when we're talking about a thin application. When we have applications like this for a tack coat, what we're building in is failures that look like this. You've got a thin layer over top, you didn't bond it to the surface below, and with traffic and loading, there's nothing preventing it from moving away. And unfortunately, we can find slides of this elsewhere. So getting a good tack is key. And, don't just put it down once, put it down, in your head. Remember, tack coat, tack coat, tack coat. The other thing you have to worry about is your staging. Occasionally, the delivery truck will come in and pick up the tack, and that needs to be addressed, either using a material transfer device. There are spray pavers out there, but just making sure that you're not losing your tack, because when you see things like this, we're right in the wheel path where the delivery truck was, you'll see the ThinLays pull up. And here's another example as well. With regard to compaction, it's a little challenging to get density, but you can use nuclear gauge cores are a little challenging because we are talking about a thin application. But making sure you keep temperature of your mix, establish your roller pattern and stick to it, and make sure those rollers are really close to the paver. A tool that's available that you're free to download, Minnesota Department of Transportation developed something called Pave Cool, and this will tell you how much time your window is for getting on and then getting off the pavement. It's a mobile app, which works really good in the construction side of the house. So here's the screen from Pave Cool. You'll put things in it like what's the air temperature, the wind speed, the latitude you are out on the pavement structure, and then how thick you're placing down, whether it's a fine or a dense graded mix. And then what it'll give you back is the window of opportunity to compact that pavement. So you want to wait about 7 minutes before you get on it with your breakdown roller, and then you have a window up to 43 minutes. Now, Pave Cool will tell us as we get thinner, like an inch overlay, that those numbers change. So when we put in the same information and we drop it down to a 1 inch, all of a sudden, now you have to get on it and off it in about 11 minutes. And that's a tight window. So your rollers need to know their job, the operators need to know their job, and they really need to do good practices. Here's another example I threw in. I mentioned HIMAs are really common, that you're going to do highly modified asphalt within them. 1 inch, 7622, 39 latitude is where I'm standing right now in Ellicott City, Maryland. A little bit cooler day than that previous one. A little bit wind, surface temperature just slightly below. They're placing the material at around 300 degrees. And in Pave Cool, you see a really tight window for this. So either we need to elevate the temperature a little bit and lay down, but really making sure the rollers get on, get in, get off, and get it down. Budge mentioned a number of these. One of the things that confused me when I first came to NCAT is the PG study. When I hear PG, just my background in super pave, as Travis mentioned, that's performance grade asphalt. Well, no, PG is the preservation group study for ThinLays. And there's a wealth of information out there if you go out to NCAT's website and look at the preservation work. Here we have projects that are both with NCAT and also MinRoad. They're the southern and northern climate sections that were placed. Looking at thin overlays, nominal maximum size, 4.5. Looking at the inclusion of both virgin materials, but also asphalt binder replacement with RAP and RAS. Neat and modified, so really the whole gambit there. And within this study, we're seeing preservation techniques that are extending life from 4 to 11 years. And the 11 years gets me very excited. Just think about, you know, putting down a thin overlay and increasing your life over a decade. And these have been placed over sections, existing pavements, chip seals, and CR bases as well. So to let you get your eyes on this slide here, the upper slides are the northern sections, so they're up in Minnesota. The lower slides are the southern slides, so they're down in Alabama on Lee Road, County Road 159. And the key across the bottom shows you after loading, if it's green, it's good. If it's yellow, it's fair. If it's red, it's poor. You'll notice there's no poor, and there's only one fair in this with regard to cracking on the one section. And these are our virgin ThinLays. So no recycled material, straight up. And you can see the sections as they've gone down. Here's one with asphalt binder replacement, both wrap and raz. There was not a southern section here on Ebro, but there was one out at US 280. A little bit of cracking, but only in the fair range, and doing really good in the low volume range on the northern climates as well. Another shot from Lee County Road. Here we have 50% wrap in a ThinLay and also 5% raz. We're seeing cracking, but the cracks are in the low to moderate thickness, low on the 50% wrap, low to moderate opening on the raz side of the house. This is the outbound lane from a quarry, so they're receiving very heavy loading as well. And here we're going to show ThinLays over a fiber mat chip. If you're not familiar with fiber mat, this is a product that Kolos has a special paver that does a spray, drops the fiber, does another spray on top of it, so you get a in-place built fiber mat. And here is the data from the fiber mat placement as well. So we've got in the northern sections, no rutting, pretty good ride, more in the fair side of the house after loading and treatment, and similarly on the outbound lane at Lee County Road and also US 280. And here's an example where it was put down on Cold Central Plant recycling, and you know, really good looking pavement after a lot of heavy loads coming out of the quarry. So obviously these data shows that there's benefits. We both look at the warm climates down in Alabama, the cold climates up in Minnesota. Different concerns, and the warmer climates worried about oxidation and fatigue cracking. If you get up in Minnesota, thermal cracking is the name of the game that you're trying to reduce. And showing some of the work that Adriana has put together, we're able to show that there is a definite extension of life that occurs with the ThinLay on it. The red line is the control section, no treatment, and then the blue line is showing after the treatment of the ThinLay. And here we have an extension of cracking in Lee County Road, where we've retarded the cracking an additional 8 years. And it's hard to predict the point out here, but definitely performing better about on Minnesota 8. So for the southern climate, when we look at it, here's the whole gamut of treatments from virgin down to 5% raz. When you look at the initial condition, remember, structurally sound pavement with something minor that you're trying to address. We're seeing time to pour 10-year extension on most of these, except for the 50 and 5% wrap and raz, but there we're still getting 7 years plus. On our northern climate, starting out the initial condition, good to fair. And again, seeing from 7.5 to 10 years extension of life with the ThinLay on top of it. So really looks good. With that, I'm going to hand it back to Buzz for a second. He's going to talk about the takeaways. Now, Buzz, do you have these in your presentation, or do you want to work off of my slides?
Well, actually, we're going to go to Jim first, and then I'm going to come back after Jim with takeaways.
Perfect, man. I like that. I like that. Omaha.
That's right, Omaha.
Okay, hopefully, hopefully you guys can see my screen and hear me. Everything good?
We hear you, but you're not there you go.
There you are.
There you
You're
go.
in presentation mode now. Thanks, Jim.
Yep, good
Looks
deal.
and sounds good, Jim.
Okay, thank you. Okay, good morning, everyone. What I'd like to do is you can hear a little bit of repetition here in some of my content with Tom, but I'm going to tell you the Ohio story with regard to ThinLays. We have a bit of a history, and hopefully you can learn something from us today. As Tom said, ThinLay is a nationally established term that represents a preservation treatment using a thin asphalt pavement layer. In Ohio, it's typically 5/8 to 1 inch thin. Nationally, it seems like oftentimes you hear the 3/4 inch minimum, but I think the 5/8 actually comes from Ohio, and I'll tell you about that in a minute. ThinLays are strictly for use on structurally sound pavements, so we're looking for no fatigue failures, no full depth cracks, and no structural rutting. The beauty of ThinLays is they're non-proprietary. Any asphalt producer can make a ThinLay, and any contractor can place a ThinLay. You don't need special pavers or other special equipment. The Ohio ThinLay options, we have two specifications. Our smooth seal option is the oldest specification we have, and our ThinLay is a relatively new spec, and I'll tell you about those here in a minute. Okay, ThinLay benefits. There's a lot of benefits, and I might not necessarily cover every one of these, but you can read along with me. But especially when you compare to our competitors, our competing treatments, ThinLay asphalt offers a lot of benefits, and the first, maybe the most important, or one of the most important, is you seal the pavement. It corrects functional pavement deficiencies, and although not intended as a structural improvement, whenever you add thickness, even 3/4 or an inch thickness, you do provide some modest, strength or structural improvements to your pavement. So it does help. You true up the pavement both longitudinally and transversely, which means you're improving drainage, surface drainage, you're improving ride quality, you're improving or restoring surface friction, reducing noise in some cases. And since you're doing a preservation treatment, you're reducing life cycle costs of the pavement. In addition, ThinLays are known to handle high traffic without surface degradation in general. You don't have the aggregate loss, the dust generation, binder runoff that you might see with some other treatments. Minimum user delays with traffic. There's no cure time really associated with the ThinLay treatment. If you're placing a ThinLay in an urban or suburban area, there's no loss or minimal loss of curb reveal, which is always a good thing. There's also minimum adjustments with regard to castings. And it engenders public support. High quality pavement surfaces are preferred by residents and motorists. And ThinLays also support alternative transportation types. Biking, cycling, walking, even skateboarding and rollerblading are certainly more popular on asphalt, concrete, and ThinLay surfaces than some of the other surface treatments that we see. And ThinLays are sustainable. ThinLays can be recycled, and many mixes allow wrap. Okay, I always like to include this graph in my presentations. We stole this from NCAT research a number of years ago, and the reason I like to show this is because I mentioned sealing the pavement and the importance of that, and I think that's one of the greatest benefits of ThinLays is if you can keep water and air and oxygen outside of the pavement, particularly in northern climates, that goes a long way towards preserving your pavement and extending life. And this graph basically shows that 9.5 millimeter mixes and below have very low permeabilities. Even if you have air voids in the 6, 7, 8% range, the permeability is very low. So that's the beauty of the ThinLay mixes. If you're talking about a 6.3 mix or a 4.75 mix, you have very low permeability, so you keep that pavement sealed. Okay, the types of candidate projects that we would use a ThinLay surface treatment on are dry-looking, bony pavements, oxidized pavements. They may be porous, they may be permeable. The pavements may have begun to ravel to different levels. Some pavements, occasionally you might have some minor flushing or bleeding. Those are good candidates. Pavement with cracking too fine or too extensive for crack sealing. We're not talking about, serious, severe, open, wide cracking. We're talking about, fine cracking, hairline type cracking, basically, related to environmental, oxidation conditions. Pavements where curb reveal does not permit heavy lift thicknesses, and pavements considered fair and good based upon pavement management systems. So we're talking about either PCRs or PCI ratings, generally in the 60 to 85 range, and that those numbers can vary based on your agency, but those are generally the areas for preventive maintenance treatments. Okay, in addition, candidate pavements shall have no unrepaired structural damage. If you do have structural damage that needs to be repaired, Tom had mentioned that. You can address minor rutting. Less than a quarter inch is acceptable, but anything more than that, you would either have to mill the surface, or you would actually have to investigate the pavement to determine if the rutting is limited to the surface, or if it goes down into underlying asphalt layers, or maybe even subgrade issues. So minor rutting is acceptable, and the pavement needs to have sufficient structural capacity to last the life of the ThinLay treatment. You're not going to use a ThinLay as a Band-Aid treatment. We're looking to preserve the pavement and extend life. Okay, the first specification I'm going to talk about is known as Smooth Seal. This is ODOT's, the Ohio DOT's fine graded polymer asphalt concrete, and this is Ohio's original ThinLay specification. This specification is kind of unique. It has two different mixes included in the specification. The Type A mix was actually introduced in the early 1970s. So I think it's probably safe that I can say that Ohio was building ThinLays before our industry even recognized we had ThinLays. But we started in the 70s, and this is a recipe mix designed for lighter medium traffic applications. This is basically a sand asphalt. It's a blend of sands with 8.5% polymer modified asphalt binder, and we require a 7622M. When the mix was first introduced, we would typically get an SBR latex modified binder. Today, it's more common to get an SBS modified binder just due to availability and other factors. The specification also has a silica dioxide requirement on the fine aggregate to ensure good skid resistance. This is the highest polymer dosage in Ohio's market, which provides enhanced toughness, stability, and long-term performance. And this is the mix that is typically placed at 5/8 of an inch in many cases, or 3/4. 3/4 is not uncommon. Typical max is 1 inch thick for the Type A mix. And for the Type A, we have an expected service life of generally speaking 10 or more years. It's not uncommon to see 15 to 20 years. And we know of at least one road. It was a residential street in a Cleveland suburb where we had a 5/8 of an inch, Type A mix that lasted at least 27 years. We never did find out exactly when the city resurfaced and replaced the roadway, but we know it lasted at least 27 years. Okay, first picture, just to kind of give you an idea, obviously 100% sand mix. It's a very, very fine, very tight, very smooth mix. This is placement of a 5/8 inch overlay on a state route and an arterial in a Cleveland suburb. This is another suburban application, an arterial. This project at the time of the picture is approximately 5 years old, and I drive that street pretty regularly. That mix is still in place. It's 17 years old right now, and it's cracked, but it's still black. It's still relatively smooth, and it's certainly functional. It's with very few potholes, so it's still performing quite well at 17 years. And this is an installation, a construction of a Type A in the city of Canton. So it's not uncommon to see the Type A mix, the sand asphalt, used in cities primarily in Northeast Ohio. In fact, that's one limitation with the mix. It's an Ohio specification, but it is pretty much limited. The use of the Type A mix is pretty much limited to Northeast Ohio. basically the Cleveland, Akron, Youngstown, Canton areas. It is used occasionally outside of that region, but it's fairly rare, and it's that that northeast part of the state that has the greatest amount of sands and silicon dioxide sands. So that's why it seems to have a little bit greater use. The last picture I thought I'd throw in here, just this is one of the more unique applications for a type A smooth seal mix. This is a project that was built last year, and it was new construction, a new covered bridge. This is in Holmes County in the Mohican Park area of Ohio, central Ohio. Very beautiful scenic area, but I just thought I'd throw it in there just to show that these mixes have been around so long. They're certainly used as ThinLays, but we've had so much success with some of these mixes that they're even used as specified as the surface course on some projects, unique projects. And in this case, it was applied a little bit thicker than the ThinLay, but nonetheless, that's a very nice treatment on that particular project. I was actually impressed when I saw that job, so it turned out quite well. Okay, the second mix in the item 424 specification is the type B smooth seal, and this is the mix that basically probably most of you may have heard of one time or another. This is what really started the smooth seal terminology. This was when ODOT started getting serious about preservation. This mix was introduced in 2001, late 2001, early 2002. The type A mix was a recipe. The type B mix here is a Marshall design volumetric mix. This mix can be designed for medium or heavy traffic applications. This is considered the 4.75 en masse mix, which when it comes to ThinLay, that seems to be probably the most common, at least that I hear. I know Tom had mentioned 9.5 millimeter in some cases, but in Buzz as well. But 4.75 seems to be the most common ThinLay mix. Basically, we have a minimum binder content of 6.7 in this particular mix. And once again, we're using a 76-22 binder. Mix design requires a 15% VMA and a design air voids of 4%. So also has the silicon dioxide requirement on fine aggregate for friction, surface friction. One of the higher polymer dosages in Ohio mixes. We do permit wrap in the type B mix, up to 10% is permitted. And this mix is typically placed at 3/4 of an inch or 1 inch. It started out as 3/4, and it seems like most designers and most agencies have kind of moved to the 1 inch application in most cases. I did throw in the gradation chart on the lower right there. It's a little bit small, but if you wanted an idea on gradation between the type A and type B mixes, you can see reference the table there. And as far as expected service life for the type B mix, it's generally seems to be in the 10 to 15 year range. It's not uncommon at all with this mix. However, it depends upon what type of pavement you're basically placing the mix upon. In Ohio, we have a lot of composite pavements. A lot of our interstates started out as concrete pavements, and they evolved into composites as they aged and were repaired and resurfaced. And I have part of my background at ODOT was in the maintenance area, and in my opinion, a composite pavement is the most challenging pavement to maintain, and regardless of what type of mix you put on there, but especially if you're putting a thin overlay over an old composite pavement, it's very challenging to maintain and control reflective cracking. So we might see a little bit lower service life if you're placing these mixes on older composite pavements, but if you place them on full depth asphalt, it's not uncommon to see 10 or 15 years or more in some cases. And there's a picture of the 424B. Once again, very, very smooth, very tight, it's a very fine mix, but not quite as fine as the type A. This was one of the very first type B mixes placed on a state highway out in the Toledo area back in, I think it was 2002 when that was constructed. This is a typical 2-lane route. This is in Geauga County, just a 2-lane resurfacing, a typical smooth seal application. And this mix also, I mentioned, can be designed for heavy traffic, and it's not uncommon. It's performed very well. This is I-71 in the Cleveland area, but it's performed on interstates with over 100,000 vehicles per day. So this mix is very reliable and durable and well regarded within our industry. Just to show you the difference between the two mix, if you saw cut a core, you can kind of see why the Type A mix is it's very rich. It stays black the entire life of the project, and you can see how fine it is. And obviously the Type B is a little bit larger aggregate, a little more structure, a little more strength, a little more stability to be rut resistant under heavier traffic. You can disregard the supplemental spec 854. That was an old spec, but that's what the two mixes look like. Okay, now I'm going to move on to the our newest spec, our ThinLay asphalt. This was introduced in 2016, and we added a rejuvenating agent to the specification in 2020. Volumetric mix design. The industry specification has 4 mixes. The ODOT supplemental spec 860 includes 2 of the 4 mixes, and I'll show you more about that in a minute. These are considered 6.3 millimeter en masse mixes, different binder contents and different binders based upon the traffic designs. I'll show you more in a minute. Thickness for a ThinLay is typically 3/4 of an inch. Occasionally it's placed at an inch, but typically at 3/4. Acceptance for this mix is usually gradation and binder content, and expected service life is still being determined. This is a new spec. Our oldest projects right now are just over 7 years old. So we do expect 6 or 7 years to probably 10 or 12 years of life out of this mix, depending upon the underlying pavement you're dealing with. Real quick, just to show you the 4 mixes in the industry specification. We have a mix designed for heavy, medium, light, and ultralight traffic. And you can see the different traffic characteristics that help you decide what mix is appropriate for your roadway. Medium light is included in the ODOT specification. They felt that those were the 2 mixes that were most appropriate for ODOT state highways. And as far as composition, I'm not going to spend much time here, but just want to show you that the heavy and medium mixes tend to have more crushed aggregates, light and ultralight, more natural materials, less crush requirements, reduced crush requirements. Binder contents are slightly different, a little bit lower binder for heavy and medium, a little bit higher for the light and ultralight, and then different binders based upon traffic. We require a 7022 polymer binder for heavy, a standard 6422 for medium, and then we're actually using some softer binders. First time in Ohio in a surface course, we're using a 5828 or a 52-28 in light or ultralight traffic applications. ThinLays first constructed, the very first project was in 2016, Arnold Road in the greater Dayton area. Typical 2-lane project built about the same time. That was a light design, a 5828 mix. This was a medium ThinLay. This is part of what we call it the Solver Research Project in Ohio. ODOT has a Southern Ohio low volume experimental road project. Has about 6 or 7 sections with different treatments, and a ThinLay is one of those treatments we're monitoring. A couple subsequent projects built in 18 and 19. This was a medium ThinLay built in the Ashland area. This was a gorgeous mix here. This was an ultralight ThinLay placed on a state highway before ODOT decided they wouldn't use the ultralight mix. Nonetheless, this was a beautiful mix placed on Route 3 in the Worcester area. It's performing quite well. This is a unique mix. This is in the Cleveland area. This is a medium design ThinLay, but it was set up as per plan. And this particular district requires polymer binders in their surface courses, and they also blend aggregates. So they require either air-cooled blast furnace slag or trap rock from Ontario. So this surface is a medium design mix with a heavy binder and blended aggregates for skids. The lines you see on the pavement there are due to the utility lines above, so that's not in the pavement. Those are shadows from the utility lines. And the last picture here is a medium ThinLay built in the greater Toledo area. That was also a really nice looking job. And last but not least is this is one of our more recent projects, and this was a ThinLay built on the state route north of Dayton. These pictures are, really show off the mat and the texture, and these are really beautiful mixes when you get them right, and everything goes as planned. And there's a lot of potential for ThinLay mixes in our opinion. Okay, moving on real quick. To improve quality and optimize performance, select the proper mix specification based on traffic. Ensure your project qualifies as a preservation treatment. Perform quality repairs when needed. Construct repairs flush with the existing pavement. Avoid leaving repairs high or low. And if milling the surface for uniformity or aggregate interlock, perform the repairs first, then plane the pavement. Manufacturing ThinLays, if it's a normal non-polymer binder, it's just like conventional mixes. If you specify a polymer binder, you need greater heat during production, greater heat at the project site. You need the heat to compact. You don't want it to drain down. You're looking for at least 290, 300 generally on site, and you can use warm mix additives in ThinLay mixes. To ensure quality paving job, make sure you place the material on a clean and dry and adequately prepared pavement. Place the mix at least at a 60-degree Fahrenheit surface and air temperature. Tom talked about tack coat. Ensure uniform application tack and allow for setting prior to paving. Determine the time to compact. Thin layers cool rapidly. Our ThinLay specification requires that pave cool be run daily, every paving day. The ThinLay project has to run pave cool to determine that time for compaction. To ensure a quality job, avoid using pneumatic rollers on polymer mixes. Use only static, non-vibratory rollers. Construct hot joints or thoroughly coat the joint with a certified PG binder. In Ohio, we do consider and we do use longitudinal joint adhesives to help with longitudinal joint performance. Tom talked about the importance of coordinating plant, trucking, and paver. That is critical. That thin lifts, there's not a lot of room for error here. You want to pave for smoothness. You want to minimize paver stops. You want to minimize handwork. And the acceptance of most of these mixes is usually based upon gradation and binder content. Some mixes you can use, the 424B does use a density gauge for acceptance. Most density gauges, at least the ones I've heard about, generally have a 3/4 inch minimum, and some people are kind of leery about using gauges on 3/4 inch, but on a 1 inch lift, you certainly can. Tom also mentioned tack coat. This is just some additional recommendations for any ThinLay or single course overlay. In Ohio, we do recommend we do use non-cracking tack quite a bit. Proper rate applied uniformly, like Tom talked about, is critical. And if milling on a ThinLay project or any single lift project for that matter, in Ohio, we recommend a fine planing to get the finer texture on the left side of the photo down here, as opposed to conventional milling on the right. Just provides a finer texture, more uniform surface, it's more conducive to achieving density and smoothness. So we highly recommend fine planing for thin overlays. In conclusion, ThinLay can be a key component to your agency's asset management strategy. It facilitates extended structural life and improves pavement functional characteristics while providing maximum satisfaction to road users at a reasonable cost. And that's pretty much the end of my presentation. Travis or Buzz, it's all yours.
That was a great, great presentation there, Jim. I enjoyed that personally very much. So thank you so much for sharing that. And I'm gonna take back over with the screen, and I'm gonna jump into implementation takeaways before I hand it back off to Travis. To pull all this together, to attempt to pull all this together. Of course, down here at Auburn, we have a long history of track performance on and off the track, and also up in Minnesota with these smaller, finer 475 NMAS ThinLays. Tom Harmon mentioned Napa's information series 141 on ThinLays. That's a great reference. And Tom, I talked about this recently, and one of the cautions that I often tell people about regarding all the information series documents. If you Google these documents, oftentimes, and the ThinLay document is one of those. If you just Google it, it'll actually take you to an older version of that document that's like 20 plus years old. That will be like a free PDF. If you want the information series, you may have to, depending on who you are and whether you're a NAPA member or not, you may have to actually go to the NAPA store and purchase it. But I'm really promoting heynapa.com, because you can go through heynapa.com, create a username and a password, free access. There's no charge for that at all. And HeyNapa actually has like 1,000 documents as its reference sources. It will take you to information series 141. It'll be the new version. And if you use HeyNapa, you don't have to actually buy the information series documents. HeyNapa will take you to them directly, and you can use them as a reference. So I just want to point that out to people. Google is kind of dangerous when it comes to the information series documents, because it will take you to the old versions. But HeyNapa, you need to be using HeyNapa if you haven't experimented with it, because it's a wonderful tool.
Hey,
Tom,
Buzz.
yes.
I used HeyNapa. I asked it a simple question. What are the most important things for consideration in putting down ThinLays? And it pulled up a whole bunch of information, and I made sure its key points were also the key points that we talked about. And it's been fun to see. We keep reinforcing all the things that are in it. So yeah, it's a really fun tool to use.
It's very, very useful. So yeah, when I'm going out and building new presentations with Asphalt Pavement Alliance, HeyNapa is a primary source document for me. And if you're a contractor, or if you're state or city or county or whatever, it's free and it's a great tool for you. So thank you for that comment, Tom. Tom also talked about the mixed varieties and Everyday Count 6, the targeted overlay pavement solutions program. So we talk often about the dense graded ThinLays, but there's lots of options. I love the dense graded ThinLays because we have the opportunity to utilize what I refer to as surplus stone screenings or gravel sand stockpiles, because as we process our, in our quarries, when we process for super paved, kind of typical super paved type stockpiles, we end up in some jurisdictions with large surpluses of these smaller materials, and we can use them. One of the themes throughout all the presentations today really is health. These are healthy mixes. Construction quality is super important, but construction quality is easier to achieve with healthy mixes. And so Bill Pine and I have kind of settled on using this terminology. Mixed performance is really all about the quality and the quantity of the effective binder content. And so these are relatively rich mixes you've seen in all the presentations that were made today that have a really healthy quality and quantity of effective binder content. I would encourage you to go to ncat.us, click on the preservation tab on the upper right-hand corner of the web page, and it will take you into the web tool that Dr. Adriana Vargas and her students developed so that you can actually go into our PG data, and you can look at ThinLays, you can look at microsurface, you can look at chip seals, and with the performance curves for different levels of pretreatment condition. Very, very useful tool, and my hat's off to Adriana for developing that. Very, very useful. So Jim gave a great presentation, and I kind of summarized that with qualified, positive, long-term Ohio experience with both smooth seals and ThinLays. Both of those are mixed types that have really healthy quality and quantity of effective binder content, but they're careful about. He gave a lot of qualifications for the jobs that you need to use these mixes on. He talked about the benefits. You're sealing the structure, you get a little bit of structural benefit. It trues up the profile, the longitudinal and the transverse profile. You can correct some drainage issues, get good ride. You can improve the ride, improve the friction, improve the noise. Get a good life cycle investment as a result of the work that you're doing. And there are a lot of public benefits, like the ones that we don't usually think about for municipal applications, for skateboarding and for cycling all those things. There are a lot of public benefits to these types of mixes, and so the bottom line to this, as in all of our presentations, is it's really all about safe and sustainable pavements at the lowest possible life cycle cost. And I think these ThinLays are really important tool in the toolbox in order to achieve that. So we're at the top of the hour. If y'all want to do a kind of a screen grab of all 4 of our email addresses, there we are on this page. And Travis, before I hand it back off to you, I want to advertise, if you haven't already registered for the track conference and you would like to attend, that is May the 7th, 8th, and 9th here at Auburn. And Travis provided this QR code that you can click on that will take you straight to the conference registration website. That's going to be 2.5 days of implementation focus with tours. It's a great experience if you've never had the opportunity to do that. We always also like to promote training in your pocket. This whole web series is incredibly useful because they're short, entertaining videos, and you can use them to orient new employees or maybe tune up existing employees. And they're not like regular technical videos where we tend to use too many words and make them so long that people's eyes glaze over. These are very well done and in an appropriate length. We also promote all of the training programs here at NCAT that are executed underneath Travis, that Tom is also extremely involved in. You can see all these at ncat.us. And finally, as I hand back off to Travis, the next webinar is going to be different, and this is actually, the idea for this came from a presentation that I did recently in New Jersey at their annual meeting, and it's going to be on asphalt use for sports courts, trails, and other non-traditional applications. That's on April the 18th. So Travis, I'll turn it back over to you for any kind of Q&A you might want to do.
Awesome. Thanks, Buzz. Thank you very much. There were a couple questions that came in. There was one on some profile milling. There was one on tack coats and spray pavers and use of the nuclear density gauges. I think a lot of those got answered, and especially Buzz, you answered several of those in the chat. Hopefully everybody got that. One I didn't really see an answer for, maybe you can spend just a moment on, is have you had any experience using GPR on the ThinLays? I know that GPR was used on the last track build. I'm not positive if there were any ThinLays that were used at that time.
We have not used GPR on anything that I would classify as a ThinLay. As Tom said, the definition of a ThinLay is 1.5 inches or thinner. We did use GPR on the Mississippi section that would meet that definition. But for me and for my practice, I consider it to be a ThinLay if it's 1 inch or thinner, and typically 3/4 inch. And so we've not done any kind of rigorous GPR type of analysis on those types of mixes. But the nice thing about those mixes is that I think we have, several of us have stated, because they're smaller, they're finer, they're richer. They become I think Tom showed us, maybe Jim showed the slide, but they become impermeable at lower levels of density, and they're easy to compact. I can't imagine with a really healthy ThinLay how it's possible to undercompact it. So,
yeah. One of the other things I want to add in there from our discussions in the past is that, using some of these screenings that normally would be considered waste in a thin mix, I think is a fantastic way to utilize the resources that we already have and get these mixes that we're finding really do perform very well. So, Buzzer, is there any of those other points that you wanted to speak on real quickly before we shut down?
That were in the chat box?
Yes, sir.
Well, the one thing that I think is pretty important, depending on where you're working, is the spray pavers. And we've done a lot of test sections with spray pavers, and so the question about can you use spray pavers, because of the higher tack rate that you can shoot, when you use them. And I was with Alabama DOT actually when Tom was working on supporting and promoting super pave implementation, and at that time, sort of the sales pitch for spray pavers was, well, this is a gap graded mix, so so the emulsion water can escape from the mat behind the screed as it flash breaks because of the heat of the mix. And the concern I've got with dense graded versions of ThinLays is that still true? Can the water still get out? And if it can't get out, is there some negative impact on long-term bond strength or some stripping potential at the bottom of that layer? I think we need to answer those questions, but there are some state agencies that are specifying the use of spray pavers with dense graded mixes because they want that high attack rate. And to me, the jury's out on that. I would be very cautious about that, but spray pavers are great with those gap graded mixes that they were originally developed to place.
Great.
Jim and Tom, do y'all have any thoughts on that?
No, I tend to agree with you, Buzz. I mean, I have a little experience with this spray paver years ago, but it was with the gap graded mixes that you're referring to. So you were kind of cautious in Ohio because our industry isn't really geared up with that equipment. So we kind of stick with the ThinLays that I presented and conventional pavers, and we've stayed away from the spray pavers for the most part.
Great. Okay, good deal.
Tom,
Given that, we're bit. What's that?
I was just
My only
Tom,
comment is if you have access to a spray paver, this is a good application for it. But yeah, I don't know that it needs to be spec'd.
one of the things that we didn't, I know we're at the end and we're over time, Travis, but one of the things that we didn't really talk about was, we assume that we can't get significant smoothness improvements many times with agencies with ThinLays, but we've seen the exact opposite because we put ThinLays on 2 different test sections for Alabama. One of them was only a ½ inch thick, and it was just a dense graded ThinLay, and we went from 350 inches per mile on a really thick, really rough thick lay placement down to about 150 inches per mile, which is still that's not a smooth road. That's not an excessively smooth road, but
it's a significant improvement.
That's an incredible roughness reduction just from that ThinLay. And then we thought, well, it got smoother, but surely it's the roughness is going to reflect of that underlying mix, and the roughness never reflected. So I kind of learned 2 different things, kind of broke some of my biased thinking with the placement of those test sections. So, and that was kind of what drove my answer to the profile milling question. The transverse profile is really way more important than the longitudinal profile, I think, with the ThinLays, because you don't want to drag the screed depending on how thick you're paving.
Okay, sounds good. Want to thank Jim, Tom, and Buzz for this very informative thing. This has been a wonderful webinar today. Great information there. I do want to reiterate one thing we heard from all 3 of them is that you must pick a road that's appropriate for this ThinLay. They're putting it on a road that's already in structural failure or has significant distresses that are deep is just not the appropriate way to find success with these thin mixes. So given that, I want to again invite you back next month. That QR code that Buzz showed is live, and anytime you find that QR code for this series, that does point you to the next one. And we'll see you then next time. Thank you very much.